Okay, so last time we were talking about, well, kind of thinking about taking our next step towards programmatically creating our department or something like that. In order to do that, we need to be able to represent the rooms and dimensions and things like that in the department in some sort of interesting way. So we talked about data representation languages a little bit and kind of talked about the history of this with HTML, and then how XML was the kind of said, hey, let's take the HTML tag-based approach and let's make a way of representing data other than website type data. And then more recently, we use something called JSON, JavaScript Object Notation, which is the same syntax that JavaScript uses for representing its objects. So as an example, a patient record in XML might look like this, where we have a first name, last name, and a date of birth. So one of the issues with XML is that there's a lot of fluff to hold relatively little data, where the JSON representation of that same thing looks something like this. So kind of, first of all, we got to consider who's going to be using these data representation languages. It's probably going to be programmers, right? So a programmer could be the same programmer or might be two different programmers who work on two separate programs. And they need to send data between these programs, so we can think about it like sending an object. So I wrote a program that uses patient records, and you wrote a program that also uses patient records. We kind of agree upon what patient records look like. We're going to say that their first name, last names, and date of birth. So now we need to have a convenient way of sending stuff from my program to your program, and from your program back to my program. Since these guys are sitting on different machines somewhere, over the internet, whatever, let's kind of forget about there's something called HIPAA laws, HIPAA compliance that deals with how do you securely transmit health records and stuff like that. We'll pretend like we're before that existed, and we're just going to say that we can just throw it all out there, no problem, no big deal. So now we need to have a way of getting that stuff over the internet. Now, just think about the ways that we use the internet today. Excuse me. So, you commonly do web browsing, right? And so if you were to kind of give me the generic definition of what's happening behind the scenes with web browsing, what would you say? So web browsing, you're using Chrome or something, right? Okay. What do you do what's the use case for Chrome? You open up Chrome, and what are you gonna do? Search something, type in a web address. Okay. So you're putting something in a bar somewhere, right? You're pressing enter, and what happens with that data?
Program read it and look for it.
Look for it where?
Through a database.
What if your computer's not hooked to the internet?
Then it doesn't work.
So Chrome doesn't work then. Okay, so really what you're saying is that little toolbar is magic. It's a place where magic happens. Okay, so let me throw this up there. All right, so we're going to use a web browser as an example of how we might need multiple programs to send data between each other, right? Okay, so in a web browser, our use case is we type in a URL or a search term, something like that. What happens with that? That gets sent over the internet, because you said if we're not connected to the internet, it doesn't work, right? Okay, this gets sent over the internet. Where do you think it goes? Okay, server somewhere. All right, so it gets sent over into the internet. If it's a URL, it gets sent to the most local DNS server. Because if you type in like www.google.com and press enter, that google.com needs to get translated into an IP address. Okay, so something needs to happen to the data. We don't need to go into too much depth about what actually happens on the internet. But if you type in google.com, it gets sent to the local Concordia DNS server first. So the DNS network is a connection of servers where the idea is that there's a global collection of 5 or 6 different DNS servers that should have all web addresses mapped to their IP addresses. But rather than sending all requests to that one giant machine somewhere, that collection of giant machines, why don't we go ahead and let Concordia traffic hit Concordia's DNS server first and see if they can do the reverse lookup. So what does Concordia's machine have? Chances are lots of people go to Google here, right? So chances are they already have the mapping for google.com to the actual IP address for Google. So if you type in google.com and press enter, it's going to hit some machine across campus here, which is our DNS server. And it's going to say, please turn google.com into its equivalent IP address. So kind of this is a similar to with your cell phones. If you want to call your friend, you tap on their picture, right? That's the google.com thing. And then that translates it to their actual phone number, which you maybe don't have memorized anymore. Do you know any, other than your own phone number, do you know anybody else's phone number?
Yeah.
Like you actually remember your parents' number? See, the only other number that I think I could get 100% from heart would be my wife's number. And most of that has to do with that we specifically picked it to be like very close to my number. Otherwise, I might be sketch on that. We've become so reliant on technology, right? You know, in fact, we don't even look for pictures anymore. I just tell my, phone to call mom or something. It just does the magic. You know, would you like to call home or mobile? And, that kind of stuff. But in any case, if you're using a web browser, you type in a URL, it's going to go to a DNS server. And if our local DNS server doesn't have the lookup, it's going to jump to the next one, so on and so forth, until it finally gets up to a top level tower that will give it do the lookup or tell you this address doesn't exist. Okay. If it's a search term, which is actually a much more recent thing. I mean, typically when you put up in that URL bar, historically has always been a web address, not a search term. Typically, if you wanted to do a search, you would go to google.com and then you would type in your search. Well, as you pointed out, a pretty high percentage of the time when you go to the web, you're doing a search. So they've just built it into the browsers where you can kind of select which search engine you want to be your default one for that URL bar. So if you type in a search term up there and press enter, it'll use that default engine to do your search. Okay. Now, what that's doing is it's sending information from the web browser. So if you're saying you want to, search for MBA scores, something like that, it's going to send that over the internet to Google's web server. We're using Google. Okay. If it's a search term, send over the internet to Google's server, something like that. Okay. Now, when we say send something over the internet, what does that imply? All right, so if I'm going to send something from this computer to another computer over the internet, what has to happen? We talked about this last time, but from the other side. So now we're connecting the dots. Okay, so I typed in a search term. I'm searching for last night's MBA scores. I press enter. Okay, by this last slide, we say since it's a search term, we're going to send this over the internet. We're presuming we're going to use Google search engine. So this is going to go to Google's server. How does that actually happen? So Chrome is a computer program, right? Pick your favorite browser or whatever. Okay, so we have Chrome. And then we have Google search server, something like that. All right. So ultimately, we want to send our request for last night's NBA scores over the internet to Google search server. This guy is going to do that work for us, right? Because we're not relying on our local Chrome browser to search the entire internet. Chances are Google has some magic over there. Go ahead.
Is Chrome I'm assuming Chrome just is a user-friendly way of packaging the information, making a package to send for the user, and then it goes to your router or whatever, and then and then that finds the Google search server, and then it makes a request as the package that it sends is a request for this information.
Okay.
And then the server sends it back.
Okay. All good stuff. Let's take away some of the network crap of it that we already talked about. Let's focus on the package part of it. All right. So when I press enter on Chrome, it's going to package up my request in some way to send it over the internet. So if I want to draw a little line here. So I'll just put a little placeholder here for right now. So packaged search request. And then we're going to draw another line coming back. And this guy's going to be a package search result, right? All right, so now we want to figure out what does packaged mean? How is it packaged up? Now, the issue here is it's so easy for us to think about this as being this foreign entity, this server thing, and Chrome being this simple thing, oh, it's just a web browser, right? But at its heart, isn't this a computer program? And isn't this guy running a computer program? So when we say we're talking to Google search server, what we're actually doing is talking to a computer program that's running on Google search server. That's what's actually happening. So we have one computer program talking to another computer program, generically speaking. Okay, so when we need to send data, when we type something in on Chrome and we need to send data to this other program, we need to package it up in some way. Okay, and since we're dealing with internet data here, does anybody know how internet data is packaged up? We did talk about it last time, but we didn't mention the word package. These guys speak a common language. So since we're using the internet as our go-between, okay, we've agreed that this is a web browser. This is a web server. These guys have agreed upon a language to speak to each other, and that language is called HTTP, Hypertext Transport Protocol. Okay, you remember from last time what does Hypertext Transport Protocol give us? 4 functions. Would have made a really good quiz. So we have put, post, get, delete. It gives us 4 functions that have been around since the beginning of the internet. Web was something right there at the very beginning of the internet, and we had this thing called the HTTP protocol for sending stuff over the internet using the web, using web browsers and web servers. Okay, so first of all, in computer science, well, in technology in general, whenever you hear the word protocol, we instantly think something is way more complicated than it is, right? Like Hypertext Transport Protocol. Just throwing protocol into the end of it makes it seem more techy, okay? We are all speaking the English protocol right now. That's a lot less scary because we're very used to English and it's not a big problem for us and all sorts of stuff like that, right? All this is an agreed upon language for these guys to talk to each other. That's it. All right. So they're talking to each other in terms of this structured communication. So we have all these rules associated with English. So when words come out of my mouth, the idea is that they should be formatted in a way that you can then interpret. So I'm packaging them in English, sending them out across the, it's a distributed send, okay? I'm sending it across the airwaves here. Your ears are receiving that packaged English protocol. Then you're unpackaging it inside your brain and giving semantics to it, giving meaning to what you just received, right? Web browser, web server, okay? And if I ask a question, then what do? You spit the answer back. So I'm making a request, you're sending a response. Same exact thing. But we're used to doing it as humans, so that made more sense than working on the internet, right? Even though this is the same thing, exact same thing. But probably a lot more simplified, right? You know, we think English is being simple, but English is one of the harder languages in the world to learn. At least I've been told that. You know, we all grew up with it, so it's didn't seem all that necessarily difficult. Everybody eventually gets it at some point. But if when you talk to international students and they had to learn languages in their countries, English is pretty tough to pick up. You know, the language. What language intimidates you the most if you were going to go and learn another language? Yeah. Like Chinese seems terrifying to me. Like I'd really like to learn it, but you just like you immediately get. Well, I immediately just get turned away. Like when you start seeing the random symbols and stuff, just the kanji characters. Russian uses the Cyrillic alphabet, but so yeah. Although that seems less intimidating. That looks cooler to me. I mean, like Chinese seems impossible. Like it's just pictures and stuff, right? Like how do you know that you have to draw that little tiny line here that instead it's got to be angled a little bit instead of straight across like another symbol? You may have two symbols that look almost the same. And I have bad handwriting. So that's not going to really come across. But Russian, they use Cyrillic characters, so you can as an American, you can almost try to pronounce it, but like not quite because they got like weird stuff we're not used to. Yeah.
Is that with Chinese? Like there's the base like characters, and then there's like the more like extra ones. Like I guess it's like English. Like there's like the normal words.
Yeah, there's simplified Chinese that has made that I think my guess was introduced for the rest of the world to have like a fighting chance or something like that. But and then I think it's kanji. That might be Japanese, but I think they maybe share. Part of that might be made up. But I think it's the kanji alphabet is like a whole bunch of traditional symbols. I think kind of what you're saying, where there's a much larger language where a single symbol has like a meaning. It's almost like a hieroglyphic type thing. It's not just a word, it's an idea or something. So, but anyways, Chinese seems incredibly complicated to me and like impossible. And I'm just going to stick to bad English and enough Spanish to order at Taco Bell. That's that's my go-to move. Do any of you know another language like fluently? Spanish? Did you learn it in school or a relative?
My parents.
Okay, so you like grew up speaking both? Yeah, my wife, she won some. I mean, she learned it in school, and she won some award in high school for I don't know, honorary Mexican or something like that. Like top Spanish student in the state of Illinois or something, and like she can she can academically do it, but she couldn't understand somebody or speak it. Yeah, so she has to order in English at Taco Bell. I don't know. Do you just go in with Spanish and Taco Bell and then watch them?
I'm way more fluent in understanding. Like I'm not really a talker, so.
I see. You can. If somebody's speaking it to you, you got it, but you're not necessarily going to spit it back to them in Spanish. That's really a funny thing to go into Taco Bell and order in Spanish. Nobody's going to get you. All right. So in any case, even though this is, tech jargon, it means the same thing as us talking to each other in English. Me sending a request, packaging it up in English, you processing it in your brain and sending a response back. Okay? So how we package something has to be agreed upon between two machines. Make sense? So these guys have been around forever and ever and ever. Well, 40 years, 30 some years, whatever. for HTTP. So this was the agreed upon protocol for web browser stuff to talk to each other. Okay, web stuff to talk to each other. All right, so then, so let's say we use that as a model. There's plenty of other models. There's a thing called FTP, File Transfer Protocol, where you have a FTP client, you have an FTP server, and the client wants to either send a file or download a file from the server, and it's going to make its request, package it up using the FTP language, send it, the server is going to receive it, process what it was just asked, so it's going to unpackage it, give meaning to it, do what it was supposed to do, send it back. Make sense? Same exact cadence no matter what we're doing. So out there on the internet, we have a whole bunch of these protocols. Now, all right, so what's the point of a protocol? So we really have two sides to this. One is to send/receive data. Okay, so I like the phrase package because I think that really the network technical term is packet, but package makes, I think, a lot of sense. Where we have a whole bunch of stuff inside this package. Okay, some of it's the data. Okay, the data we're sending or receiving, whatever, that's in there. But then there's going to be some context to it. Like, what are we going to do with this data? All right, so we have send and receive data, and then we have instructions, what to do. All right, so now in the English language, we have a vast array of different instructions we can give, right? A whole bunch of options. So we can say that the English protocol is very complex. If I'm asking you a question, the only prediction you would have in the classroom would be, he's probably going to ask a question related to the topic of this class, right? But with me, that might be out the window anyway, since I get off topic all the time. Okay, so it basically becomes a crapshoot, right? But you can kind of departmentalize, what you think the question might be, so that you maybe can, give meaning to it a little bit quicker, that kind of thing. So instead of searching your entire database of knowledge, you kind of put yourself into game programming mode, something like this class mode, like, okay, what did we talk about last time, that type of thing. And then when I ask questions, you kind of search there first. Make sense? Okay. Now, what I just described is kind of scoping rules in programming, right? Okay, so now the reality is that we see all of our technology. What's our technology's job? It's to solve problems in a way similar to how we're already used to solving them. But we have to represent it in technology. So programming, even as foreign as it might sound, is actually a protocol that we're using to speak to, in a lot of cases, a compiler or an interpreter, to give it ultimately instructions to talk to the CPU. So it goes through all these different layers. Right? But those scoping rules right there is modeled after the way we do things. Okay? We have kind of our, compartmentalized knowledge, like, okay, we're going to load this up because I'm going to probably need this knowledge for this class. Or maybe my English class this afternoon, I'm not going to really need to reference that stuff for my morning class. So we're going to kind of keep that on the back burner for right now. So we'll check that local knowledge first. All right. But with English, that protocol, it's a really, really complex protocol. When I ask a question, that question could be almost anything, right? Only compartmentalized based on maybe we're having a conversation about a certain topic, okay? Which is always funny when you're talking to somebody about something and all of a sudden they ask something just completely from left field. That kind of stumbles you for a second because you have to like switch your interpretation engine. They're asking you about somebody's birthday when you were just talking about politics or something like that. Okay, you're totally off the off the reservation. Okay, but punchline here is that English is really, really complicated. The protocols that we're using to create between languages are significantly simpler. Okay, because we're asking far fewer types of questions. So when we think about a web browser and a web server, what's the nature of the data we might be sending between a web browser and a web server? Well, we talked about you might type in a search term, something like that. That's just a string. right? Like, here's some text I want. Google, you've made $1 zillion creating a magical tool that can take text and turn it into search results somehow, right? I mean, we can sit here and try to write our own little search engine that would be some kind of approximation of Google, just like if I do, my own hand-drawn art, it's an approximation of some famous artist, right? Not quite the same thing, but it's an approximation. So we could write something that was, search engine-esque, but we all kind of appreciate that Google's done something magical behind the scenes that's worth money, right? Because that's why we use it. That's why we choose Google, or we choose Bing, or whatever your search engine of choice is. I'm going to guess we're probably 90% Google. Anybody in here choose Bing? Is there another one? I think Ask Jeeves is making a comeback. You've heard of that one, right?
Yeah.
Yeah.
I've seen people use Opera too.
Well, Opera's a browser.
Yeah, but yeah, sorry.
Yeah, the browsers would be. I think we have a little bit more across the board buy-in for browsers. Chrome's pretty popular, but so is what was Internet Explorer. Now it's Microsoft Edge. I think most technology people do not use Edge, but I think Edge might be one of the more popular browsers overall because that's where Grandpa clicks. The internet lives behind the blue E. Right, that's where the internet is the blue E, and then you have Safari, like he mentioned, Opera. Opera's kind of a somewhat of a, I don't know, how would we say it? Opera's not popular, but it's something that people still use somewhat. But these are tools that we are picking, but ultimately at the end of the day, that's the tool. But when we're sending data from any web browser into the server, the nature of that data might just be a string, right? Might just be a string. Okay. Or we mentioned that it could also be a URL coming from the web browser, but that's actually not even getting to the web server, that URL. The URL is actually we're immediately, the browser recognizes that, oh, you're typing in a web address, not a search term. So since you're typing in a web address, we're going to go ahead and we're going to send that to the local DNS server and try to figure out where do you actually want to go. Do a lookup and get the phone number, the IP address for that guy. Okay. So generally speaking, if we're using a protocol, we have data, we have instructions. The data, if we are talking about a web browser, yeah, so Tor is for the dark web. Okay. Yeah, so it's that's a false statement. Tor is a cryptography-based web browser, so and it attempts to make you completely anonymous. Okay, so that's the Tor protocol, is as a goal of anonymity. It's often used for browsing the dark web, which is a bunch of sites not indexed by Google, used for nefarious purposes. Mostly. I'm sure there are some sites on dark web that are, let's call them legitimate, but I would question why they're on the dark web at that point. Yeah, there's some scary stuff on the dark web. If you were to academically check it out sometime, it's scary. Yeah, not just, you got your obvious, right? It's drugs and things like that, but you could hire a hitman. And it's not as expensive as it should be. If you it's it really is scary. I give a student a D, something like that. Potentially on a student's budget, they could, especially if you're pooling resources. I might not be here next week is the punchline. And it's real. They've created the eBay of Hitman, where you can apply there as a service provider. Military experience and all this stuff. There's some stuff out there that we probably wish was not out there, but whatever. But that's what Tor is. Tor is that security browser. So in any case, with a web browser, nature of data is going to be something in the ballpark of string-based. Maybe this is search terms. Actually, I'm going to kick it down a line here just to expedite this a little bit. So we're going to say nature of data coming from a web browser might be string-based search terms. That's kind of the simplest form of this, right? Okay. Now, sometimes when you're on a web browser, you might put in like a username or password, right? Or you might fill out a form. You're registering for an account. So you have 5 or 6 pieces of information on there, and you fill out a bunch of forms and you hit a little submit button at the bottom, right? Okay. So what that's going to do is it's going to package up that information in some sort of format to keep a bunch of name value pairs. That make sense? So now we're actually here talking about the predecessor to XML or JSON. Okay, because that data, so in a let's just say registration form. Data is packaged inside a get or post request to transmit to the server. All right, and if you remember, I guess it's on the next slide. So RESTful APIs leverage, do I have HTTP here somewhere? So HTTP has these 4 functions: put, post, delete, and get. Post and get are functions that are commonly used, and if you've ever been on a website that uses a get, you have a form, you submit it, you'll see like maybe you have first name, last name, and date of birth. It'll be up in the URL when it's sending it. So they'll say F name is equal to this, and L name is equal to this, and date of birth is equal to this. So it'll all be up there in the URL, plainly readable. All right, so you can actually see that request that's getting sent across. So that information is being packaged along with the URL so that the server can then grab those 3 pieces of information. So that's one way of sending non-HTTP, non-traditional HTML information to a web server. All right, but we'll call that somewhat proprietary. That's something that's based on how the GET package works with HTTP. Similarly, what the POST package does is it's a more behind the scenes. It creates a little package and throws the stuff in it. So the POST package has a whole bunch of different information, including the name value pairs that you pass along. All right, that the server can then receive. It grabs the POST package, it opens it up, and grabs the pieces of information that it cares about for the request you made. Okay, so we're going to call that more of a proprietary approach, but still an example of your web browser talking to the web server, or an example of a program talking to another program, sending data to another program for a request. All right, so we're seeing this type of thing modeled for us from years and years and years and years ago. But back then we were using more proprietary or at least secondary approaches. So just like when I walked into this room, I presumed, not just based on past experience, but based on the rules set up by the server that is Concordia, that the protocol that we will all use is English, right? That's kind of a setup rule. Nobody actually, probably provided that to you on paper, although I bet you it's in like the student handbook somewhere. It's probably in there somewhere. But the presumption was when you applied to a university in the middle of Wisconsin, chances are English was going to be that default language, right? Okay, so we've agreed upon that. Just like web browsers, web servers, they've agreed upon, probably by force, the people who wrote it, to use the HTTP language. All right, so now when we abstract this, I'm going to take this slide here. I'm going to drop it. Let me just see what I put right after. Yeah, let's drop it here. So I'm going to modify this. How do we send data between two programs. I'll use the term protocol. All right, so now we're looking at this from the perspective of generically, we have two computer programs, whether one of them is a server or one of them's not. I mean, that has more to do with like the networking type thing where we have this client server model where the client makes requests to the server sends responses back. You know, in this case, we might just have two programs that have something to do with each other. Right, that need to get data between the two programs. The relationship between these two programs might not even be anything like client server. So this program, if it needs to send something or request information from this program, it's going to package up a request where the request can have data in it, things like that, and send it to it. Okay. Similarly, when it sends stuff back, it's going to package it up. Now, what we can do is we can have a proprietary protocol for every two programs that have a relationship with each other. And that's the way it worked for a long, long time. Okay, so if 20 years ago I was writing a program and you were writing a program, you know, we would jump on a phone call and say, okay, well, now we have to figure out, you know, when I need this information from you, what should it look like when I ask you for it? So we're kind of inventing our own little language, right? So it's almost like the signs they use in baseball when they're making them steal and stuff like that, where they have all sorts of gibberish they do, and then but one of those things is a sign. I always wondered what happens when like a player gets traded to another team. Do they have to change all their signs? You know what I mean?
Oh,
like in the middle of the season, if a player was playing for the Brewers, so he knows all the Brewers signs. And then he gets traded to the Cubs. So now you have a Cubs player who knows all the Brewers signs. Does it got to change him? That seems inconvenient. I wonder if they do it like on a per day basis. Like maybe they have a set of, I don't know, 15 signs or something like that. And on a given day before a game, they mention this is what the steal sign is out of those symbols.
You said what?
What's it? That's how I was back in the Little League. I never actually knew the signs. I
feel like the pitcher would be fair enough. Or the catcher. You know what I mean?
What would?
Get to determine his own signs.
Well, that's for the pit. That's for the pitcher. But I think that, you know, for fastball, curveball, whatever, where on the plate. But I think that's more standardized because that's hidden. You know, he's doing it down in a way where other people can't necessarily see it unless you have the vantage point from the, you know, from the camera view up high or something. So I'm not sure that needs to necessarily change. But like when you have like the third base coach giving signs to the guy on, you know, the runner on first, whether he should steal second.
Yeah.
That type of thing. I mean, that's much more out in the open, right? Where, you know, you don't want somebody in the opposing team's dugout to see that and then signal the pitcher that the guy's about to steal or something, because then things get funny.
Probably just something subtle like.
Well, yeah, but it still has to change. It is something subtle. I mean, a lot of times you watch them, you know, they do things like this, and you know, they're pulling on their ear. You know, it's like stuff like that. But some of that or some combination of that means steal. So they have a protocol, but that protocol might be changing, you know, on a per game basis or something like that, especially as you have players that move between teams that might now know. I've always wondered the same thing with like the NFL, the same issue. You got a quarterback calling plays, you know, like blue 32 or, you know, whatever this stuff is. You know, so if a guy was on the, you know, the Packers and he knew what blue 32 was, then he gets traded to, you know, the team the Packers are playing next week. All of a sudden, Rogers is making calls, and the guy on the other side knows exactly what play they're about to run. See, these are interesting problems, right? They got to encrypt that stuff. All right, so historically, and even modernly, I suppose, we might have proprietary ways for two programs to talk to each other. But now we take it to the next level. So we might say, is it common for two or more computer programs to talk to each other today? Is that common? Super common, right? In fact, we would be hard pressed to find a computer program today that wasn't online in some way, right? So this is a big yes. It's a medium-sized yes, actually, but now it's a big yes. there's a big yes. All right, so with that in mind, with technology, would it have made some sense for us to come up with some sort of standardized way for computer programs to, so here, I'll throw this in it. Does it make sense for there to be a standardized way for programs to talk? Again, another big yes, right? But then so we'll say yes, but then I'll ask the question, why? Well, we have the obvious, right? Well, if they're doing it all the time, we might as well have a standardized way of doing it. We model that all the time in real life, correct? Human beings talk to each other all the time. So we've all agreed upon, at least here, we've agreed upon English as being our standardized way of communicating, okay, regardless of what's on our mind or what we're talking about, whatever. So we have this agreed upon way. And why is that easier? Well, wouldn't it be really inconvenient if you and I had a special language and then you and you had a different language? So you had to kind of move into, I mean, first of all, that would be weird to like learn all these different languages, right? But there are places in the world where it's kind of like that. Not maybe to the extreme where it's on a per individual basis, but when I was in India, because there's so many different languages in India, you might literally have two towns right next to each other that have trouble communicating with each other. So, just in the area of India where I was, which is like their tech center, Hyderabad speaks Telugu. That state speaks Telugu. And the state right next to it speaks Tamil. So it would be equivalent to like Wisconsin speaking, well, we'll just use the same language, Telugu, and Illinois speaking Tamil. Well, yeah. I mean, just like here. I mean, if you're at a McDonald's in Illinois, you can, minus like Cubs versus Wisconsin hats, would you be able to tell the difference between what a Wisconsin person looked like versus what an Illinois person? Well, the big, but on both sides, yeah. I mean, India has huge population, so I mean, there's just people everywhere. But yeah, I mean, it would really be that type of thing. Where you cross the border into Illinois, you walk into a McDonald's and you can't order because you're speaking Telugu and the person at the window there is speaking Tamil. So then you have the state language or the country language in India, which is Hindi, which actually a surprisingly few number of people speak, relatively speaking. So they actually default to English. It's completely common to be walking in a store or something like that in India and hearing two Indian people talking to each other in English.
Wasn't that like a whole like European stuff or territory.
Well, yeah, I mean, Britain used to run the place, so yeah, there was that. So maybe that encouraged it down a certain path, but also, the world economy tends to run on English now. That's just what happened. America became United States became a big world power, runs the economy. The rest of the world says, okay, well, we got to go speak to the dumb Americans. So they're talking English, so we better speak English too, something like that. Okay, but we can agree it would be inconvenient if you couldn't turn to your neighbor and speak the same language as you would speak to your other neighbor, right? It would be inconvenient for us to have proprietary protocols for each student at the university for you to talk to. That's an extreme example, but even if there was 3 or 4, maybe you have different groups of people. Maybe all the males spoke to each other with one language and all the females spoke to each other with another language. And then when the males spoke to females or the females spoke to males, they used a third language. That's kind of more like in the realm of plausible, but would still be inconvenient, right? Yeah, that would just be weird. So take it back to the history of writing software, and we might be sitting in the situation where every single computer program that comes out has some sort of proprietary protocol that is speaking to its complementary program, some program it's using to, get database stuff from or whatever. That becomes problematic, right? So it makes sense. I don't think this is a big question, a difficult question. Does it make sense for there to be a standardized way for programs to talk? Sure, that makes a lot of sense. The obvious reason why, from a just human perspective, is because it's easier, right? It's more convenient to do that. What might be another reason from a technology perspective?
It's like more open source, how people build off of.
Okay, yeah, I mean, I think that's kind of getting into it. So, if it is open source, what does it mean for something to be open source?
It's basically
Yeah, so the little language that these two computer programs are talking to each other with isn't like a secret language. It's not the steal from first to second base baseball language, right? It's completely public language. We said these are the types of things we ask each other, and this is how we ask it. Okay, very public. All right. So if it's open source, we can, let's say something like this. Programming languages can include parsers for working with languages of, well, let's call it protocols. In that format. So last time we looked at XML and JSON and things like that, we kind of appreciate the fact that has a format to it, right? With XML, it's kind of a tag-based format. With JSON, it's the curly brace and comma-based format. So it has a format to it that does not necessarily dictate the data that's actually being sent, right? I mean, I can use JSON to send a first name, a last name, and a date of birth. I can also use JSON to send stats relative to a baseball card. Okay, both of them look like JSON. Both of them could be parsed by a generic JSON capable parser that would pull the pieces of data out. And then as the end user, if I'm one of those two computer programs, if I say, I know I'm receiving a string in JSON format, I'm going to now split that up. And now, because I'm the computer program that knows I'm talking to this computer program, I know what data was likely in that package. So I can start looking for those pieces of data. Okay, but I can now have a generic parser that knows how to work with JSON data, or a generic parser that knows how to work with XML data. And so now it's helpful for us in terms of programmers to have something like that built into our languages, because we don't have to write our own parser. Does that make sense? So So we introduced these couple of topics here. So serialize, also called Marshall with that many L's. I probably couldn't decide if it was one L or two L's. So I just put a bunch of L's. Okay, so this takes from an object form into a data representation form. So that's a generic term. So the JSON version of this would be, I have an object, I want to turn that object into JSON. Okay, so let's take a look at that from a programmatic perspective. All right, let's see. I can show this in Unity. I happen to be using Unity here, but I'm actually just going to create a standard C# object. So we're going to start moving in the direction where having things stored as objects might be beneficial for us. All right, so I'm in my scripts folder here. I'm going to go ahead and I'm going to create a C# script, and we're going to call this guy, just since it's been part of our example, let's just call it patient record. We'll end up deleting it later, but fair enough. So I'm going to create something called patient record. Now we know that when I first create an object here in Unity, it's going to make it a normal Unity script with an update method and all that stuff. So I'm going to go ahead and double click on this, and we're going to doctor it up a little bit. Okay, so right off the bat here, I'm going to say that this patient record is no longer a mono behavior. So this is the inheritance model in C# where we say, here's the class I'm creating here called patient record. And by default, Unity said that this guy extends a class called mono behavior. And mono behavior is the dude that says, here's an update method that gets called every frame. Here's a fixed update. Here's start. Here's awake. All these things like that. That is what we've been used to using with scripting for Unity. Okay, so by me taking away that mono behavior thing, this guy no longer plays by the rules of Unity. I'm creating just a normal plain Jane object. Okay, so I can go ahead and get rid of, these functions I can leave in there, but they no longer will automatically get called and things like that because I'm no longer playing by Unity's rules. I'm just creating a normal object in C# is what I'm doing here. Make sense? All right, so we have patient record here. Now we might want to have a couple of variables associated with our patient record. So maybe we say we're going to have a private string fname, a private string lname, and a private, we'll just leave it as a string, date of birth. So 3 different pieces of information associated with a patient record. Okay, so then we'll have our constructor for this guy. This guy will take in a string fname, string lname, string date of birth, and we'll say this dot fname is equal to fname, this dot lname is equal to lname, this dot date of birth is equal to date of birth, like that. All right, so most of you in here have seen Java before, right? Doesn't that look like a Java object? Almost identically, right? In fact, when you look at this, the only thing that's different here is that string starts with a lowercase s instead of an uppercase s. Otherwise, could I copy and paste this code into a Java program and have it just work? Yeah. That goes back to our, if you remember in like 200 when we had the history of languages, we had Java and then next to it, just down a little bit, was C#. These languages are extremely related to each other because Microsoft tried to steal Java, got sued, came out with their own language, C#. You can see these guys have a lot in common. So again, this should go back to this idea that, programming is the skill set, the individual language is less important. All right, so we have a little object here. So we could build patient records if we want, but what we're interested in right now is, let's assume that I have this local program that has maybe an array of patient records or something like that. So I have a whole bunch of patient records. And I want to take a particular patient record and I want to turn it into its JSON equivalent, right? So I'm just going to say public string to JSON. And what this guy will do is he will return the JSON version of this object. Now this object happens to just hold 3 pieces of information. So just as a quick reminder, I'll just create what that JSON string would look like. So we want it to look something like this. Fname is equal to, for instance, it might be Mike. Lname is equal to Littman. Date of birth is equal to, this is going to be a string, but it's going to kind of be in a weird format, maybe. Well, whatever. We're going to say this is something like that. All right, so there's the JSON string that is representative of, that's what we want to create. Right? We want to build that string. We're going to build JSON. How can I do that? If you had a programming assignment to take an object like this that had a first name, a last name, and a date of birth, and you had to write a function called toJSON that ultimately spit out something that looked like this, how could you do that? Okay. I'm going to call this guy answer. Then what?
I think print name with space.
Okay, we don't want to print it. We want to build this string. So right off the bat, don't I want answer to look like this? Start with a curly brace. That's the first thing that was here. Right? And then I'll say answer is equal to answer concatenated with fname colon concatenated with this dot fname concatenated with a comma. Similarly, I'd say answer is equal to answer concatenated with lname, the colon, concatenated with whatever this dot lname is, concatenated with a comma. Lastly, answer is equal to answer concatenated with date of birth, colon, concatenated with this dot dob, concatenated with a closing curly brace. Return answer. Something like that. So that's allowed. Okay. Well, let's see how we can maybe use this guy. I'll just throw it into one of my. See, do any of these guys just have a Q modifier, generate board? Okay.
As long as you like label it as anything or anything else, doesn't matter. I mean, like obviously you can't concatenate it, right?
I'm not sure what question you're asking.
Like, is it for the JSON kind of thing you're trying to write? Right now, does it only work with strings?
Well, oh, you mean like F name? No, I mean, so here I could do something like private int age. Let's throw that in there.
Yeah. And then just there's the age on it.
Yeah, so this would be this dot age is equal to age, and then down here, I would just add one more thing. So this is concatenated with a comma, then answer is equal to answer concatenated with age concatenated with this dot age concatenated with the ending curly brace, like that. Yeah, so you could use different data types. Okay, so let me just go back out here to Unity real quick. Do I have anything attached to these guys? Scripts on these? All right, so what I'm going to do is I'm going to I'm just going to create an extra script. So we're going to call this guy cube patient record builder or something like that. Just going to be a quick little example of using our patient record thing. All right, so I'll go ahead and open this up. And then what I'll do is in start here, I'll go ahead and I'm going to say I'm going to create a patient record. PR is equal to a new patient record. Okay, and this guy takes in F name, L name, date of birth. So we'll say Mike Littman 12778. All right, and then we'll go ahead and say, actually, I think there's just a print command, right? So I'll say print pr.toJSON. So that's a function we wrote, the toJSON, right? That should take this object that we just built using the constructor and stuff like that. Oh, by the way, does this guy look familiar to you? Could that just as easily be Java? All right, so then we'll go ahead and use our function here, toJSON from PR. And if you want to see the other equivalent, if you're in the 250 class right now, is this a class method or an instance method? Instance method, because it doesn't have static, right? How do we call instance methods? Using an instance of the class in which it was defined. Here's my instance. Here's me calling that instance method. You see how that knowledge translates between languages? All right, so I'll go ahead and just print out my pr.toJSON, proving that it works. Okay, so what I'm going to do then is I need to attach my cube patient record builder to one of my cubes. That way I get a console output that will show this guy. So I'll just take this nice cube up here. I'm going to add a component, and we're going to call this guy cube patient record builder. All right, so I'll just add that component to that guy. So now when it first starts, just a single cube here, we'll run that script, which should build an instance of patient record and put something out to the console. And here it is. I don't know if you can see it very well, but it's the correct text. So curly brace F name colon Mike, comma L name colon Littman, comma DOB colon that, comma age colon 40, closing curly brace. So we wrote the code to build a JSON string, right? Okay. Now I want to look at an example. So in Unity, we have a, well, that's going the other direction. I want to use JSON utility to JSON. Okay, so Unity has a class called JSON utility, to JSON, that is this a class method or an instance method? Class method. How do you know? So we have the static keyword there. So we'll call this guy by saying the name of the class, JSON utility dot to JSON, and we pass it an object. So here's an example of this guy being used. So we have this thing called save to string, which converts it to JSON. So what I'm going to do is I'm just going to modify my code. Instead of me building it out, I'm going to return this JSON utility thing. So let me show you that. So I'm going to go to my patient record. So right now in patient record, I did all this stuff, right? I built this string. Well, what I'm going to do here is instead of returning that answer that I built, I'm going to return JSON utility dot to JSON, passing it this object. Okay. And what that should do is it should pull together this stuff here into my correct JSON string. So let's just run this real quick so we see it work. So really all this stuff right here is unneeded. Make sense? It was just there as a placeholder. I'm going to leave it there for right now just so I can come back to it. But the only thing I'm actually doing is I'm calling JSON utility to JSON, passing it this particular object. This is the how an object refers to itself from within itself. All right. So make sure this is saved. Go out here to Unity, stop this, run it again. Okay, and I got empty curly braces. Let's see what I'm not doing here in my, oh, they need to be public, it looks like. So in order for this to work, I have to make these guys public. So what that JSON utility must do is it must go and only look for the public variables associated with an object to build it. So let's see if that works now. Yep, there we go. So F name. Now actually I think it wrote more correct JSON than I had written. Let me see if I can copy this and bring it in. This is actually better JSON than I wrote. I wrote kind of sketchy JSON. We can fix it, but mine was sketchy. But actually, this is even a better example of why. So notice that it's pretty similar JSON, except they have double quotes around everything. All right, which actually makes this even more helpful for us. If I wanted to build this correct JSON string with the double quotes, and the real power in that is notice that the type of this guy is a string, but notice that that 40 here, the type is an int. So that goes back to what you were asking. But that where in my version of this, it wouldn't have been able to differentiate between them. But if I want to build something that looks like this, I would have to say backslash double quote there, backslash double quote there, colon, backslash double quote, backslash double quote, oh, actually, these before and after. Here, and just to prove that, I'll go ahead and print answer in here too. Oh, it doesn't know about it in the current context since this guy's not a mono behavior. Doesn't know about console either. That's fine. So I'll just concatenate on my answer to this guy. So I should have whatever JSON utility created for me, followed by a big arrow, followed by what I built. Okay. Now, since age is actually a number, I actually don't need the curly braces or the double quotes around it. So let's just see it work first, and I'll explain what all that stuff was about. All right, and this is what it produced. So those guys look the same. All right, so I did the same work as they had done. But notice I have, does anybody know what this little backslash double quote is? What's the backslash character in programming? Yeah. Yeah, so that's the effect of it. So the backslash is the escape character. And it says, whatever comes after this, treat it as that symbol, don't treat it as syntax. So by me saying backslash double quote, I'm saying this does not terminate a string. I actually want the character double quote to be included here. Does that make sense? So when we look at this, would you say that this is pretty verbose? Lots of extra little symbols in there, kind of tedious to write and stuff like that. Plus, wasn't it kind of nice that I could just call JSON utility on this and it automatically looked at all my public variables and just built the JSON string? That's pretty handy, isn't it? All right, so what we'll look at next time is how do we go the other direction, but that's our punchline there. By coming up with a standardized data representation language like JSON, now we can have something like JSON utility that can exist that allows us to conveniently work with JSON in both directions without us having to write specialized parsers for converting our objects into JSON and taking and building an object from JSON. Does that make sense? Okay, so pretty powerful stuff, but having a consistent tool for doing this while having a consistent protocol that we decide we're using to communicate between two programs allows for the existence of something like JSON utility. All right, questions, comments, concerns, bribes? All right, remember today's student, faculty, staff Bible study, got in, grub, go to the cafeteria. That's from noon to 1. Pick a sign in, get a tray, take it down to the terrace room. Free lunch. Also, plenty of room in the front row of chapel. I'll save you a seat in a few minutes.